So good. So let's then get going from the point where we were last time, which was just the flashing of Maxwell's equations that we had arrived at after complementing Ampere's law by the extra Maxwell term, okay? And we obtained these four equations here, Gauss's law, Nobody's law, Faraday's law, and Ampere-Maxwell, okay? And these are traditionally known as the four Maxwell equations. And they say that, many people say that this really contains absolutely everything you need to know. I mean, honestly, you also need to know what to do with these fields. So you need to complement this equation, of course, with the Lorentz force law that tells you how electromagnetic fields actually affect matter that is tagged by a certain charge associated to it. Okay, so it's not like this is a theory of absolutely everything, because it does not explain the origin of charge. It doesn't explain stuff like the quantization of charge, but it contains many other things that we've seen. So, I would have liked to have more time to discuss, but relativity is essentially inbuilt in those equations. In fact, historically, the development of special relativity could have occurred much earlier had people really taken a careful look and interpreted their things properly in here. See, there are many people who did essentially that, but then there was a chap, in 1905 that just went a tiny bit further than the others with a bit more interpretation and gave us special relativity. But you know all about that. Okay? So that's the statement. In a sense, we could end the course here, because if I trusted that you were able to apply all the mathematics that you know to these equations and essentially understand how to set up these equations in all the circumstances that you have, then my task as a teacher would be absolutely complete, okay? Because you know the fundamental equations and you're, very much in agreement with the statement that you need to go for the fundamentals. And if you know the fundamentals, then in principle, you've solved everything. Therefore, you can just kind of take a break and, enjoy it. However, in practice, that's not really how it goes. It helps to actually use these things in many circumstances so that you, perhaps with your imagination, are able to use them in even more different circumstances. Okay, so from now on, essentially, the course becomes almost an engineering course, because the concepts have all been introduced. The elements are all present. It's really just a question of cooking. It becomes, a cooking class from now on. Okay? So these equations are in green boxes. You know my meaning for these things. This is really stuff that you need to know by heart. So these ones, certainly, if you're going to remember 5 equations in your life, not only in this course, but maybe even in your life, let it be those equations, potentially the most useful equations, because they're very explicit, even much more explicit than something, for example, like the Schrödinger equation. It needs a lot of contextual information to use properly. But these ones, it's all directly like that. So you've seen these equations many times. I hope you're kind of becoming more and more chummy with them. That you feel that they've become second nature. But yeah, so one of the objectives of the course. Okay.